Good day. Today we're going to discuss Module 1 of CHE 2251, which is the fundamental concepts of mechanics. So to start off, we define mechanics as a branch of physical science that deals with energy and forces and their effects on bodies. There are three branches of mechanics, namely mechanics of rigid bodies, mechanics of deformable bodies, and fluid mechanics. So for this subject, we'll only be focusing on the mechanics of rigid bodies. So for rigid body mechanics, there are two branches or sub-branches under it. We have statics, which deals with equilibrium of bodies, which are either at rest or at constant velocity. And we have dynamics, which deals with the study of system of forces and its effect to motion, which are produced by the forces on the bodies. So it is subdivided into two sub-branches, kinematics and kinetics. So to define one of the major concepts in mechanics, we have forces, which are any interaction between objects. So it's an opposed force will cause or change the motion of an object and can either be a push or a pull. So it is defined or characterized by its magnitude, direction, its line of action, and its point of application. So they are expressed in newtons for the metric system and pounds for the English system. So to understand the characteristics of a force, let's say we have here a body at which we have a 10 kilonewton force acting at point A, which is oriented 45 degrees above the horizontal. So we can define the force in terms of its magnitude, which is 10 kilonewtons, and its direction, which is 45 degrees above the x-axis. Its point of application is at point A, and its sense or line of action is towards point A. So when we apply forces, basically, it will have different effects on objects or on bodies. So the effects of forces can be divided into external and internal effects. So these external forces or effects of forces are now caused by either reactive forces or applied forces. So when we say reactive forces, these are or will include normal and your frictional force, and will also include your tension and compression. For internal effects of forces, they are caused by or a result of internal or non-contact force and deformations distributed throughout your materials. For internal or non-contact forces, this would include your weight, your magnetic forces, and your elastic or spring forces. So in forces, we also apply what we call your principle of transmissibility. When we say principle of transmissibility, it states that a force may be applied at any point on its given line of action without altering the resultant effects of the force external to the rigid body on which it acts. So basically, it means you can apply your force at any point on the object as long as it will be on its line of action and it will not alter your resultant. So let's say we have here a body with points A, B, C, and D. So if I will apply a force on point A, a horizontal force on point A, I can transmit or transfer this force at point B. So there is no effect on the resultant since the force on B will still be on the same line of action as that of the force from point A. Okay, so let's have another example. So I will have a vertical force on point C. So I cannot transfer this force on point D since point C and point D have different lines of actions. So this is incorrect. So you can only transfer or apply any force at any point when they are of the same line of action. Axioms of mechanics. These are postulated theorems upon self-evident facts which cannot or are not proven mathematically but are demonstrated to be true. So it simply means they cannot be proven but they have been or they are observed to be true. So an example of your axioms for mechanics would include your parallelogram law. Also, two forces are in equilibrium only when equal magnitude, opposite in direction, and collinear in action. 3. A set of forces in equilibrium may be added to any system of forces without changing the effect of the original system. And lastly, action and reaction forces are equal but are oppositely directed. Forces. So for your forces, we have different types. The first one is your weight, expressed as W. So your weight now is a non-contact force because this is the force due to gravity. So when your force weight is concentrated, it would now act on the center of gravity of an object. And the weight now is simply the product of your mass and your gravity. And the weight will always be directed vertically downward regardless of the orientation or location of the object. But its value will depend on the location. So if a man is standing up, its weight will be directed vertically down. When sitting down, the weight will still be directed downwards. Lying down, he will still have a weight directed downwards. So on the location of objects, the weight of an object will vary based on its location or based on the gravitational acceleration. So when we are on Earth, an object that has a mass of 1 kilogram will have 9.8 Newton weight. But when it is on Mars, the 1 kilogram object will have a 3.7 Newton weight. And on the Moon, it will have a 1.6 Newton weight. So as you can see, the mass, for the same mass, it will have different values of weight depending on its location. So the next type of force that we have is the tension force or the tensile force T. The tensile force now is simply your stretching or pulling force that acts actually at the ends of a string, cord, or rope. So its direction now will always be away from the object in contact. For compression force, C or compressive force, This is now an inward force that would cause compaction or compression of the object. So since it's an inward force, its direction will always be towards the object. So for tension, it's away from the object. Compression is towards the object. So for compression, so it's towards the object causing compression. And then for your tension, it's away causing stretching of the material. So this is the difference between tension and compression. The next type of force will be present for any objects that are in contact. And these forces now will be our friction force and the normal force. For the friction force, for small f, this is a resistive force that would resist the relative motion of an object. And we have two types of your friction force, which is your static friction, which is now the force that would resist the impending or the starting motion of objects, and your kinetic friction, which resists now the existing motion or the motion after the object has started its motion. So for frictional force, since it resists motion, its direction now will always be opposite the direction of motion, and it will be parallel to the surfaces in contact. For the normal force, it is now N sub F, or for some books, it is Fn, or simply N. So to differentiate it from the unit Newton, let's use N sub F. So for the normal force, this is now the support force that would keep objects in contact. So without the normal force, the objects will be separated. So the normal force will be directed towards the object and is always perpendicular to the contact of surface. So in forces, we now have what we call a force system. So this is defined as any arrangement where two or more forces act on a body or on a group of related bodies. So in a force system, we have what we call your parallel forces, which are forces that act on parallel lines of action. We have your collinear forces, which would act on a single line of action. Coplanar forces, which are forces that lie in a single plane. And concurrent forces, that are forces whose lines of actions would pass through a common point. So to understand these different types of forces systems, let's have a simple diagram. So we have here a body acted upon by two horizontal forces. So these two forces now are parallel, though they are not on the same line of action. They are both horizontal, thus they are considered parallel forces. So for collinear forces, it would mean that they would pass through the same line of action. So they would have the same line of action, but it's not necessary that they should have the same direction. So if I will put this force on this side, they will now be considered as collinear forces. Another force system is your concurrent forces. So we have here an object or a body. So we have two forces acting on it. So these two forces are considered concurrent as they will pass through a single point or common point, which is this black point here. For coplanar forces, it means they will pass or lie on the same plane. So they would act on a single plane. So not necessary same direction and same line of action. As long as they are on the same or acting on the same plane, they are coplanar forces. So we also have other force systems which are combination of the mentioned force systems or a system wherein none of this will happen. So we have what we call the resolution of forces. This would simply mean that we would be resolving the values of your forces based on their components. So when a given force is replaced by two components which are equivalent to the given force. So this means we simply solve for the component of your force. And the component of a force are your resolved forces that are the equivalent of the force acting at some angle from the coordinate axis. So let's say we have here a given force. So its component force now will be y component or the vertical component and your x component or the horizontal component. And in computing for the components of a force based from your physics, so if we're going to use the magnitude of the force and its angle of its direction, we can now solve for your fx and fy or your x and y components as fx is equal to f cosine of theta or f sine of phi. And for fy, this can now be computed as f sine of theta or f cosine of phi. And the equation now for the force, total force using the components will be by your Pythagorean theorem, which is the square root of f or x component of f squared plus the y component of f squared. And for the angle or the tangent of the angle theta, this will now be equivalent to the ratio of your y component to the x component. So to solve for the values of the components of a force, we can also solve it using our slope of the force, which is defined by its horizontal and vertical ratio. So for your x and y components, it can be solved as for x component, f times the ratio of the horizontal to the slope, and for the y component, it can be computed as the magnitude of the force multiplied to the ratio of the vertical to the slope. So applying our Pythagorean theorem again, we can solve for the total value of the force as the square root of x component squared plus y component squared. And for your tangent theta, it's also equivalent to the ratio of the y component to the x component, given that theta should be measured from the horizontal. So a reminder, for rectangular components, we consider now the x and y components as positive if they are directed on the x or the positive x and positive y axis. And if they are directed on the negative x and negative y axis, the x and y components of the force will now be considered as a negative value. So next we have the moment of a force, which is defined as the ability of a force to produce twisting or turning effect about an axis. So basically, it is defined as the product of the force applied and its perpendicular distance from the pivot point, or what we call your fulcrum. So next we have a moment about a point. So for any point on an extended body, a force will cause a moment about that point, given that it does not pass or travel through that point. So, for example, we have this system. So this is our fulcrum or our pivot point. So a force that is applied at an extension at this point, for example, will still cause a rotation on our fulcrum or on our system. So this force will always or will cause this movement as long as it will not pass through the point. So next we have a couple, which is the moment produced by two equal, opposite, and non-collinear forces. So they have unique properties and important applications in mechanics. So to understand what is a couple, let's say we have here an object with point O as our reference or pivot point, which is acted upon by force F, two force F, which are equal in magnitude, opposite in direction, and are non-collinear. So, if we're going to take now the moment of each forces at point O, we'll now have negative F, since it will cause a negative rotation or counterclockwise rotation. So times its perpendicular distance, lever arm A, plus positive F times its distance from O, which is A plus D. Expanding now this equation will arrive at negative FA plus FD. So this two cancels out. So we'll have now the moment of a couple will be equivalent to force times D, or the distance between the two forces. So we have our equivalent couple, which means these are two couples that produce a moment with the same magnitude and direction. So for this example, so we have forces that act on this side of a block. So it will cause a counterclockwise rotation along or about the y-axis. So it will also have the same rotation caused when we apply the forces at the bottom surface or perpendicularly at the two surface or at the bottom surface. And even if we have our block, it will still produce the same rotation, given that the force applied will be twice or double. So the resultant couple of a moment will be determined with the equation MR is equal to M1 plus M2. So if we have two couples acting on a system, their resultant will simply be their sum. So we also have what we call the Cartesian vector formulation, into which position vectors and forces can be expressed as Cartesian vectors if the x, y, and z axes are established. So for position vector, we denote this as D, and its vector or unit vectors will now be D sub x, D sub y, and D sub z. And for our forces or force vector, F, it will now have its unit vectors equivalent, which is F sub x, F sub y, and F sub z. Expanding the formula of moment as a cross product, which is force times distance. So this will now result to an expanded equation And this will be our final answer. So this is the same as the formula from your modules. Okay, so we'll only have a negative value for this, since in your module this is d times f. So for Cartesian vector formulation, it would simply mean that we would express the values of our moments in terms of our unit vectors. So this one now becomes mi, mj, and mk. Okay? So we have Varignon's theorem. So this is the theorem that the moment of a force is the algebraic sum of the moment of its vector components acting at a common point on the line of action of the force. So it would simply be the sum of the moment is equal to the algebraic sum of the moment per component. To further understand our discussion, let's solve some sample problems. So we have problem number 1. Determine the x and y components of f sub 1, f sub 2, and f sub 3 acting on the bracket on the given illustration. So express each force as a Cartesian vector. So to solve for our problem, we have to identify our x and y components. So for f1, given now the angle 35 degrees above the horizontal, so we can solve for fx as 600 newtons cosine of 35. And for f1 y component, it will now be 600 newtons sine 35. So it will give us a value of 491.491 to the right or to the positive direction. And for the y component, it will be 344.146 newtons upwards, or a positive value. So we can express it in Cartesian vector. So in Cartesian, or as a Cartesian vector, this can now be written as x is I, y is j. So this will be 491.491 I plus 344.146 j newtons. Okay. Next, we have for force 2. For the x component and the y component, since we do not have an angle given, then we cannot use the first equation or the first way of solution. So for force 2, the given is the slope. So we now use the ratio of the slope to the horizontal and vertical. So for f2x, this will be equivalent to 4 over 5 times 500. And for f2y component, it will be 3 over 5 times 500. And this will result to 400 newtons and 300 newtons. So for the Cartesian vector for f2, this will now be negative 400i as it is directed to the left, plus 300j as it is directed upwards. And then lastly, we have for f3, we do not have an angle and the slope is not given, but the distances from point A to point B are given. So with this, we can solve for the distances and we can solve for the slope. So for f3, we know now that the horizontal is 0.2 meters and the vertical is 0.4 meters. So we can solve for the slope of the vector. Therefore, we can now solve f2 or f3x is equal to 800 times 0.2 times the slope of 0.447. And for f3 y component, it will now be 0.4 over 0.447 times 800. So this will now give us a value of 357.941 newtons and 715.542 newtons. So as a Cartesian vector, F3 now can be written as 357.941 I minus 715.542 J. So basically, the sign conventions will be based on the direction of the forces. So if we are to the right or upwards, we will have a positive sign. If the direction of the force is downwards or to the left, we will have a negative sign convention. So next we have problem number 2. From the given figure, the force F now acts on the frame, which is equivalent to 450 pounds. So let's solve for the force components acting along the members AB and AC, and let's determine the magnitude of each component. So for this, to solve for the magnitude of each component, we can now solve it by drawing a force triangle, since we have three forces acting on the system. So we have force on AC, force on AB, and the vertical force F. So you can draw your triangle anyway as long as you follow the orientation. So since we do not need the direction of our forces, we could assume the direction of the force, except for 450, since it's given that it is a downward force. So from the diagram, the angle between 450 and AB is 45 degrees, and the angle between AB and AC is 30 degrees. So this is 30 degrees. So we now use sine law. So we start off first with AC. AC over sine 45 is equal to 450 over sine of 30. So AC will be equivalent to 636.396 pounds. And then we have for AB, this is now AB over sine 105. So 105 is taken from 180 minus 45 minus 30, and it's equivalent to 450 divided by sine 30, and it will give us a value of 869.333 pounds. So we can use this if we are only solving for the magnitude of the force. If we want to solve for the direction, we will have another way of solving the values. So next problem, we have a body resting on an inclined plane is subjected to vertical and horizontal forces as shown. Determine the components of each force with respect to the x and y axis. So instead of horizontal and vertical as our x and y, we'll now have an inclined axis. So with this, we draw first an FBD, or a free body diagram of the system. So we have here your x-axis, and then we have here your y-axis. So we have your force P and force F. So from the diagram, we have a slope which is 3:4. So let's assume that this angle, or the angle of the incline to the horizontal, is theta. So we could also say that this angle is also theta, and this angle is also theta. So with that, opposite of theta is the 3 side, and the adjacent side of theta is the 4. Okay? So from this diagram, we can now solve for the components of force P and force F. So for force P, we have here your Px directed to the negative direction of the x-axis, and y, or Py, is directed to the negative direction of the y-axis. So for Px now, that is equal to 3/5 times 1,200, and it will give us a value of negative 720 pounds. And then for Py, that will be 4/5 times 1,200 pounds, and it will be a negative value as it is directed to the negative direction. And then let's solve for the x and y components of force F. So for x component, it's to the right or to upwards our incline, so to the positive x, and for Fy, it is directed to the negative direction. So for Fx, it will now be equivalent to 4/5 times 400. So this will give us 320 pounds. And we have for Fy, this will be 3/5 times 400, which will give us negative 240 pounds. Kindly correct this one. This should be 400. Okay. So next, we have for sample number 4, for the given diagram, compute for the moment of force F equal to 450 newtons and force P equal to 361 newtons about points A, B, C, and D. Assume a clockwise movement as a positive sign, and that the division, or one division, for the grid is equal to 1 meter. So for the solution, before we can solve for the moments of the forces, we have to solve first for the components of F and P. So in order to solve for the components of force F and force P, we base it on our diagram. So for force F, we'll have 1, 2, 3, 4 for the horizontal, and 1, 2, 3 for the vertical. So with that, we can now solve for force F, x component as 4/5 times 450, which is 360 newtons. And for Fy, that is 3/5 times 450 is equal to 270 newtons. And then for force P, we'll have 1, 2 for the horizontal, and 1, 2, 3 for the vertical. So for force P, you will now have 2 over square root of 13 times 361 for the x component, and for Py, we will have 3 over square root of 13 times 361 newtons, which will give us a value of 200.247 newtons and 300.37 newtons respectively. So from these values, we can now solve for the moment of the forces. So to solve for our moments, we have our x and y components of F. So about A, so the moment at A caused by the x component is 1, 2, 3 meters away. So we can write the equation as 360 times 3. So this is the x component of F, and this is how far it is from the point or from the pivot point. And this will give us 1080 Newton meters. It is a negative value, as if you have a pivot point at A, this force now will cause our system to go counterclockwise. And then for the y component of F about A, it is 1 meter away from the pivot point. So it will now be equivalent to 270 times 1. And it will cause a negative rotation or counterclockwise rotation. So therefore, it is negative 270 Newton per meter. So next, we can now solve for the total moment of force F at point E as simply the sum of the x and y components of the moments, which is negative 1350 Newton per or Newton meter. So next we have the moment about B. So for the x component, we now use a lever arm of 1, 2, 3. So we can write it as 360 times 3, but the direction will be clockwise. So our answer is a positive 1080 Newton meter. For the y component about B, it is 1, 2, 3, 4 meters away. That's why we use 270 times 4. And it will be a negative value as it will produce a, or it is a positive value as it will produce a clockwise rotation. So it's also 1080. So adding up the x and y components or the moments of the x and y components, we will have the moment of force F at point B is equal to positive 2160 Newton meter. So next we solve about C. So about C, the x component passes through point C. So therefore, the moment of the x component about C is multiplied to 0. And for C, for the vertical, we will have 1, 2, 3. No, this is 1, 2, 3, 4, 5. That's why it's multiplied to 5. So it will give us now 0 Newton meter for Fx and a positive 1350 Newton meter for Fy. So adding it up, the total moment at point C caused by force F is 1350 Newton meter clockwise. And then we have about D. It will now be equivalent to, for x, 1, 2, 3. So that's 360 times 3. It will cause a positive motion rotation. And for y, it is 1. And it will cause a negative rotation. So we'll have positive 1080 and negative 270, giving us a total of moment at point D equal to positive 810 Newton meter. So we just repeat the same procedure for point P. So for point P, we have here your x component and your y component. So about A, x component is 3 meters away. So we can write the equation as 200.247 times 3, giving us a value of negative 600.741 newtons. Negative as it will cause a negative motion. And then for the y component, about A, it is 2 meters away. So we can write the equation as 300.37 times 2. And the direction is a positive direction. And it will give us positive 600.741 Newton meter. And adding this up, it will give us a total moment at point E caused by force P is equal to 0. Next, we have about B. So, for the x component, it is 1, 2, 3 meters away. So, we'll have 200.247 times 3. And for the y component, it is 1, 2, 3 meters away from the pivot point B. So, for the x component, it will cause a positive rotation. So, it will give us positive 600.741. And then, for B, or for the y component, it will give us a negative value, which is 901.11. And the total moment at point B caused by force P is equal now to negative 300.369 Newton meter, or a counterclockwise rotation. And then for pivot C, again, the x component of force P passes through C. Therefore, the distance or the lever arm is equal to 0, which will give us a moment also equal to 0. And then for our y component of P, it will now be computed as 300.37 times 1, 2, 3, 4. So it will give us a counterclockwise. So it's a negative 1201.48 Newton meter. Adding this up, we'll have moment at point C caused by force P is equal to negative 1201.48 Newton meter. And lastly, about point D, our moment now caused by the x component will be 200 times 3. And for the y component, it is 300 times 2, giving us both 600.741 newtons. So, both will be a positive direction or a clockwise direction. So, the total moment of force P about point D is equal to positive 1201.48 Newton meter. If you're going to observe, our computed values are the same as the computed values in your handouts or in your modules. Though we have different ways, or the method that we have solved in this video is different from the solution in your handouts, we still arrive at the same values. So it simply means that your forces can be transmitted on any point as long as it is on the same line of action. So next, we have sample problem number 5. So determine the resultant couple acting on the plate. So we have the given diagram. So from the diagram, we have 3 couples, F1, 2, and 3. So to solve for the resultant couple, this is simply the summation of all the couples. And before that, we have to solve first for the individual moments produced by each couple. So for our solution, we apply the equation M is equal to FD. For couple 1, we'll have M1 is equal to F1D1, wherein F1 is 200, D1 is 4 feet. So it will give us a value of 800 pounds per feet. So if we're going to look at our diagram, both F1s will create a clockwise rotation. Next, we have couple 2. So we apply M2 is equal to F2D2. So M2 now is equivalent to 450 times 3, giving us M2 equivalent to 1350 pounds feet. And the rotation now of F2 or couple 2 is counterclockwise.
Mommy!
So for couple 3, we have M3 is equal to F3D3, which is 300 times 5, giving us 1500 pound-foot. And if we're going to look at the diagram, F3 will produce a clockwise rotation. And to solve for the resultant of the couple, we simply add the computed individual moments. Thus, MR is equivalent to 950 pound-feet and its direction is clockwise. So, thank you for listening. So, for your assignment, please answer, evaluate problem 1 and problem 5. Submission bin will be posted in the classroom for you to submit your solutions.